Welcome to Module 11 on factoring trinomials. Right now, make sure you have your notebook out and be ready to take notes. That way you can use your notes on the quizzes and you don't have to rewatch all the videos if you need to refer to something. Today, we're only going to be talking about one topic, factoring a trinomial. If I want to factor a trinomial, I want to look at something like the standard form. The standard form of a quadratic expression is ax squared plus bx plus c, where we have a number with an x squared plus a number with an x plus a constant. By the way, you should have a new topic on factoring a trinomial where you're writing these notes. If I have an expression like this, don't forget there's an invisible 1 in front of any variable that doesn't have a number. There is no overall GCF. There's nothing that 1x squared, 5x, and 4 can all be divided by, so there's no GCF on this one. And we're going to start by identifying A, B, and C. A is 1, B is 5, and C is 4. Once we do that, we can make what we call a factor tree or an ABC tree. So remember last time when we learned about factoring by grouping, you learned you had to have 4 terms, but our original expression has 3 terms. We need 4 terms so that we can factor by grouping. What we're going to do is replace this middle term with something that multiplies to be A times C. So A times C is 1 times 4, which is 4. But it needs to add to be B so that we can replace B. So we think through our factors of 4. 2 times 2 is 4, but 2 and 2 don't add to be 5. So we're going to use 1 and 4. 1 times 4 multiplies to be 4, and 1 plus 4 adds to be 5. We call these the magic numbers. They're magic because it allows me to replace my middle term with 2 different terms that both have an x. It's kind of like I've taken out $1 and replaced it with 4 quarters. The x squared stays the same, the 4 stays the same, but the 5x changes to 1x plus 4x. Now we're going to factor by grouping just like we learned last time. So we're going to group the first 2 together, x squared plus 1x, and the second 2 together, 4x plus 4. We're going to pull out the GCF of the first group, which is 1x, and that leaves me with x plus 1. We're going to divide out the GCF of the second group, which is 4. 4x divided by 4 is x. 4 divided by 4 is 1. Don't forget from last time we learned that the parentheses have to be the same for us to have done this correctly. If they're not, we have not done this correctly. We need to go back. But we can now finish factoring. The final factored form is, this is our common factor, x plus 1. That takes care of those 2, and I'm left with x plus 4. If I want to check, that's just multiplication. So if I want to check, I start with x plus 1 times x plus 4. And essentially, multiplication is factoring in reverse. Remember we learned about the distributive property? There are 2 things that need to be multiplied times x plus 4. X needs to be multiplied by x plus 4, and 1 needs to be multiplied by x plus 4. Now we distribute. Again, we're doing the opposite of factoring. So this becomes x squared plus 4x. We distribute this, that becomes 1x plus 4, and x squared plus 5x plus 4 takes us back to our original. We won't check every time. This is not your solution. This is just the check, so you want to be careful about that. Some people really get held up when it comes to finding the magic numbers. So would you please make a new heading in your notebook called Finding the Magic Numbers, and I want you to write this. To replace b with 2 numbers, we must find 2 numbers that add to be b, but also multiply to be a times c. So for this, I've already multiplied a times c. Your product is a times c. You want them to add to be b. I want you to pause the video and see if you can find the magic numbers. Two numbers that multiply to be -6 and add to be 1. Go ahead and do that now. If you think about things that multiply to be 6, 1 times 6 becomes 6, but there's no way for me to add or subtract 1 and 6 to make 1. So let's try going up to 2. 2 times 3 becomes 6. Ooh, if I subtracted these, they would make 1, but I'm supposed to be adding them. In order to make a positive 1, the smaller number would have to be negative, so -2 plus 3 would be positive 1, and -2 times 3 would be -6, so these are my magic numbers, -2 and 3. You pause the video and see if you can find two numbers that multiply to be 36 and add to be negative 13. Well, you should have started thinking about what numbers multiply to be 36. 1 and 36 can't add or subtract to make 13. 2 and 18 can't add or subtract to make 13. Or, yeah, to make 13. 3 and 12, nope, still doesn't work. Let's try 4. 4 and 9. Ooh, interesting. 4 and 9 would add to be positive 13. So let's think this through. If I need these to multiply to be positive 36, 4 times 9 works, but also negative 4 times negative 9 works, and negative 4 plus negative 9 is negative 13. You pause the video and see if you can find your magic numbers for two numbers that multiply to be negative 16 and add to be negative 6. You should have started off thinking about numbers that multiply to be negative 16, 1 and 16, but those don't add or subtract to make 6. Ooh, 2 and 8 are possible because if I were to subtract 2 and 8, I would get 6. So let's think through our signs. 2 times 8 is 16, but I need this to be negative 16, which means one of these has to be negative. So let's go down to the addition. If I want to add 2 and 8 to make negative 6, it looks like the larger number should be negative. So my magic numbers for that one are 2 and negative 8. So when we factor a trinomial, we want to remember that we need 4 terms to factor. So I want you to write that in your notes. To factor a trinomial, we need 4 terms to factor. When we have a trinomial, we have some work to do to get 4 terms. That's what I was showing you on the original problem. So on ALEKS, you're going to get something that looks like this, and it's going to tell you to factor. Well, first of all, you want to make sure it's in standard form. So standard form is x squared minus 11x plus 18. It already is in standard form. The x squared is first, the 11x is second, and the 18, which is the constant, is the third. There is no overall GCF. There's nothing that 1x squared and negative 11x and positive 18 can all be divided by. I'm now going to identify A, B, and C. A is 1, B is negative 11, and C is 18. A always comes from the number in front of your x squared, which in this case is the invisible 1. B always comes from the number with your x, which in this case is negative 11, and C comes from 18. Now I'm ready for step 3. I want to multiply A times C. So we're going to do 1 times 18, and that gives me 18. Now there are lots of things that multiply to be 18, 1 and 18, 2 and 9, 3 and 6, but I need these to add to be negative 11. Well, 1 times 18 isn't going to add or subtract to make 11. 2 times 9 might be possible. Let's try 2 and 9. 2 and 9 multiply to be 18, but they don't add to be negative 11. But if I make both of them negative, negative 2 times negative 9 is positive 18, and negative 2 plus negative 9 is negative 11. Now we're ready to rewrite. Remember when we rewrite, we keep A the same, so it's 1x squared. We're replacing B with 2 terms, and C stays the same. A lot of people make the mistake of putting something like negative 11 for C. C should always come from your constant. C is your 18. My magic numbers are what replace my B piece. Now we're ready to factor by grouping. I group my first two together, x squared minus 2x, and I group my second two together. Notice I always put a plus in the middle of the groups. That helps me to make fewer negative errors. Now I'm looking for a common factor of x squared and negative 2x, which should be x. X squared divided by x is x. Negative 2x divided by x is negative 2. For this one, I'm going to start by taking out a 9. Negative 9x divided by 9 is negative x, and 18 divided by 9 is 2. And I want you to notice something. These are close to being the same, but the signs are off. If I had taken out a negative 9 instead, which is why I keep that negative 9 on the inside of the parentheses, negative 9 divided by negative 9 would have made positive x, and positive 18 divided by negative 9 is negative 2, and now these match. So my GCF is x minus 2. I take that out, and that leaves me with either x plus negative 9 or x minus 9. And we're not going to check today in the interest of time and it being Summer Academy. You try this one on your own. Go ahead and pause the video. You've got x squared plus 11x plus 30. You see if you can fill this out on your own paper. Go ahead and do that now. You should have said no, there is no GCF. There's nothing that 1x squared and 11x and 30 can all be divided by. And you should have identified A as 1, B as 11, and C as 30. Then you're ready for step 3. Step 3 is where we multiply A times C, so 1 times 30 is 30. And then there are lots of options for things that multiply to be 30. 1 and 30, 2 and 15, 3 and 10, and so on. But I'm looking for two numbers that add to be 11. The numbers you should have come up with are 5 and 6. I don't need to worry about negatives. Those can both be positive. Now I'm ready to rewrite so that I have 4 terms instead of 3. 1x squared plus something and something that I'm going to replace b with plus 30. Well, that's 5x and 6x that add together to make 30. Now I'm ready to factor by grouping. I put my first two together and my second two together. Oops, my parentheses should be here. Sorry about that. Now I'm taking out the GCF from each group. 1x squared and 5x have a GCF of x. This leaves me with 1x plus 5. 6x, that's a messy x, and 30 have a GCF of 6. 6x divided by 6 is x. 30 divided by 6 is 5. These are matching as they should be, so my final factored form is x plus 5 times x plus 6. If you got that wrong, I want you to go back and find where you made your error. Look at each line and see where you're making your mistakes so that you could start to do this on your own. Now, sometimes we might need to factor out a GCF first. So for this one, we have 6w squared minus 48w minus 54. That's in standard form. We've got the number with the w squared, the number with the w, and the number by itself. But the question is there a GCF? And this time the answer is yes. We have to take that out like it's a common factor, which we did in the last lesson. 6, 48, and 54 all have a GCF of 6. So that becomes w squared, because 6w squared divided by 6 is w squared. Negative 48w divided by 6 is negative 8w. And negative 54 divided by 6 is negative 9. 6 is now one of my factors. At the end, I will have the 6 in my answer. Other than that, I'm not going to worry about it. My new A, B, and C are not 6, negative 48, and negative 54. I will not ask you to do a problem with numbers that size. Your A, B, and C are 1, negative 8, and negative 9. So now we have a trinomial that we need to factor. We need to turn that into a quaternomial, which means we need to use our ABC tree. So we're going to multiply A times C. 1 times negative 9 is negative 9. I'm looking for two numbers that multiply to be negative 9, but add to be B, and B is negative 8. So if I look at my numbers, 3 times 3 is what most people get hung up on, but we want to think that 1 and 9 are also an option. In order to make a negative 9, one of these has to be negative. I'm going to use that as negative 9 to make that negative 8 there. So now we're ready to rewrite. This becomes 1w squared. I'm going to replace b with the magic numbers. I always like to put my negative one first if just one of them is negative, and then bring down the c, minus 9. Now I'm ready to factor by grouping. I group my first two together and my second two together. That's a w that's messy. These two have a common factor of w, so w squared minus 9w. We're going to divide both sides or both of these by w, so that leaves me with w minus 9. For this one, these can only be divided by 1. There has to be a number here. We can't just leave it blank. 1w divided by 1 is just 1w. Negative 9 divided by 1 is just negative 9. These match as they should. So we take that out as our common factor, and that leaves me with w plus 1. We're not going to worry about checking our answer today. You pause the video and try this one on your own. Start by looking at your standard form, and I'll give you a hint. There is a GCF that you should be dividing out of each piece. Go ahead and pause the video and try these now. The GCF that you should have found was 5. So if we take that out, I want to divide each piece by 5. That should have left you with x squared minus 9x, and then 100 divided by 5 is 20. That means that your new A, B, and C are now A is 1, B is negative 9, and C is 20, and 5 is going to be a part of your final answer down here at the end. Now we're ready to multiply a times c. 1 times 20 is 20. We're looking for two numbers that multiply to be 20, but add to be negative 9. Well, 1 and 20 I don't think will work. 2 and 10 won't work. 3 does not go into 20. Ooh, 4 and 5 are interesting because if I added 4 and 5, I would get 9. Let's see if there's a way to make negative 9 and positive 20. Well, if both of these were negative, a negative times a negative would be a positive, and a negative plus a negative would be a negative. So I think we've got our magic numbers ready. Now we're ready to rewrite. We keep the x squared the same. We replace 9x with negative 4x and negative 5x, and we bring down the plus 20. Now we're ready to factor by grouping. We group our first two together, x squared minus 4x, and our second two together. Remember, I always put a plus in the middle, even though the 5 is a negative. That's going to go on the inside of the parentheses. We look for a GCF of the first group. X squared and negative 4x are divisible by x. That leaves me with x minus 4. Negative 5x and 20, because of that negative 5, I'm going to take out a negative 5. A negative 5 divided by a negative 5 is a positive 1x, and a 20 divided by a negative 5 is a negative 4. These now match as they should, so that leaves me with x minus 4 times x minus 5. So my final factored form is 5 times x minus 4 times x minus 5. So there are 3 factors there, and we're not going to worry about checking. Now, one good thing to know is that a is not always 1. So if we have the standard form here, 7x squared minus 5x minus 2, some of you might have gotten the impression that the GCF would be 7, but it's not. 5 and 2 are not divisible by 7. There is no GCF on this one. A is 7, B is negative 5, and C is negative 2. We still are going to work this exactly the same way. 7 times negative 2 is negative 14. So negative 14 goes there, and I need two numbers that multiply to be negative 14 and add to be negative 5. 1 and 14, no. Ooh, 2 and 7 are interesting. 2 times 7 makes 14. And if I need those to add to be negative 5, I can just make that a negative 7. Let's double check it. 2 times negative 7 is negative 14. 2 plus negative 7 is negative 5. So I think I've got my magic numbers here. Now I'm ready to rewrite. 7x squared. I like to put the negative first, so that's minus 7x. I'm replacing b, remember, so the negative 5x is gone, and I'm left with negative 2 for the constant. Now I'm ready to factor by grouping. 7x squared minus 7x plus 2x minus 2. We're going to factor out the GCF of 7. That leaves me, ooh, I want to be careful here. Both of these have an x with them, so I should have taken out a 7x. That leaves me with x minus 1 because 7x divided by 7x is 1. These have a GCF of 2, so I'm going to factor out a 2. 2x minus 2 divided by 2 leaves me with x minus 1. These match as they should, so my final factored form is the matching x minus 1, which we take out, and that leaves me with 7x plus 2. And we're not going to worry about checking today. Now, you won't always have the nice formatted box like I gave you to solve your problems with. So you're going to want to start memorizing the steps. So you want to start with your standard form, which this one already is. You want to ask yourself, is there a GCF? So the answer to that is no. And you want to identify your A, your B, and your C. So A is 2, B is negative 13, and C is 6. Now we're ready for our ABC tree, which you can make on your own. We're looking for two numbers that multiply to be 2 times 6, which is 12, and add to be negative 13. 1 and 12 might work, because if I were to add 1 and 12, that would make positive 13. If I make them both negative, negative 1 times negative 12 is positive 12. Negative 1 plus negative 12 is negative 13. So I think we've got our magic numbers here. Now we're ready to rewrite. We have 2y squared minus 1y. Don't forget to put your y's on there. When we lose the formatting, a lot of people tend to start losing their y's. The magic numbers always have the same variable as whatever b had. So that's minus 1y minus 12y. Do not put a negative 13 there. C is what comes next, so that's plus 6. Now we're going to factor by grouping. 2y squared minus 1y. I always put a plus in the middle of my parentheses, and then negative 12y plus 6. The GCF for this first group is y, so that leaves me with 2y minus 1. The GCF of the second group, I want to take out a 6, but I think I need to make that negative because of the sign situation, because I don't want a negative to be in my first term. So I'm going to divide everything by -6. That's going to leave me with 2y minus 1. These match as they should, so I'm left with 2y minus 1. That takes care of those, and I'm left with either y plus -6 or y minus 6. So this is how you would set this up if you don't have a nice printed copy of the box that I had on the other screens. You pause the video and try this one on your own. All right, you should have recognized that there was no GCF. You should have identified A, B, and C. A is equal to 9, B is equal to -17, and C is equal to -2. We're going to now look for our magic numbers. We're looking for two things that multiply to be A times C, but add to be -17, add to be B. Should be some version of 1 and 18 because 1 times 18 is 18, and 1, if I did 18 minus 1, I would get 17. Let's think about signs. The larger number is 17, so I need to make the sign on the 17 is negative, so I need to make the larger number negative. I'm ready to rewrite now. I keep my A term the same. Remember, if I have a positive and a negative for my magic numbers, I want to replace that first one with the negative. And that's plus 1y. Don't forget your y's. B had y's on those because we're replacing that. And then C is -2. I'm now ready to factor by grouping. There's my first group. There's my second group. The GCF of the first group is 9y. That leaves me with y minus 2. There is no GCF of the second group other than 1, so we have to use something there, so we must use 1. These now match as they should. We take that out. We're left with 9y plus 1. All right, this video will be available on Haiku if you need to rewatch, and will be available on each skill for Module 11 in ALEKS. These are pretty difficult concepts to learn online, so don't forget that your teachers have office hours if they need help. If you need help, you should now complete Module 11 practice problems in ALEKS by selecting Continue My Path. Don't forget that you can get an explanation and get some extra help even while you're working in ALEKS. And when you're done, you are ready to take the Module 11 quiz, so you'll go to Assignments and go to Quiz 11.